Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. We will explore how the remarkable learning capabilities of human infants can provide a powerful blueprint for creating more advanced and adaptable artificial intelligence. We will delve into the core principles of early cognitive development and discuss their potential application in the quest for artificial general intelligence. In stark contrast, human infants are masters of learning. They construct a rich and complex understanding of the world from the relatively sparse, unlabeled, and often noisy data they encounter. Their learning is incredibly efficient and flexible, allowing them to generalize from just a few examples. Within their first year, they develop intuitive understandings of physics, agency, and social interactions, driven by an innate curiosity to explore and make sense of their surroundings. This remarkable ability is what we aim to emulate in our pursuit of more robust AI. One of the key insights from infant development is the presence of innate priors or core knowledge. Infants aren't blank slates. They are born with certain pre-wired expectations about the world, such as the understanding that objects continue to exist even when out of sight, a concept known as object permanence. These innate biases act as a starting toolkit, guiding early learning. In AI, we can implement this by building architectures with inherent biases and structures, much like giving a neural network an initial understanding of certain fundamental principles, making learning more efficient. Infants are not passive recipients of information. They are active learners, constantly exploring their environment and testing hypotheses. This drive is fueled by intrinsic motivation, curiosity. They are inherently rewarded by new experiences and the reduction of uncertainty. In AI, this translates to curiosity-driven reinforcement learning, where an agent is rewarded not for achieving external goals, but for exploring novel states and improving its own understanding of the world, much like a baby experimenting with sounds or manipulating objects. A significant aspect of infant learning is its social and embodied nature. Babies learn by observing others, engaging in joint attention, focusing on the same thing as a caregiver, and interpreting social and emotional cues. Moreover, their cognitive development is deeply intertwined with their physical experiences. Touching, grasping, and manipulating objects helps them understand the world. In AI, this necessitates the development of embodied AI, where agents have a physical or virtual body to interact with their environment, and the incorporation of social learning mechanisms that allow AI to learn from human interaction and demonstration. Infants don't learn everything at once. They follow a developmental curriculum, mastering simpler skills before building upon them to acquire more complex abilities. They learn to control their gaze before reaching, and crawling before walking. This structured, incremental approach is crucial for effective learning. In AI, we can mimic this through curriculum learning, where a model is trained on a sequence of tasks of increasing difficulty, and continual learning, where the model can learn new tasks without forgetting previously learned ones. Translating these core principles into a working AI system requires a hybrid computational framework. This could involve generative world models that learn to predict and understand the environment, modular reinforcement learning systems driven by intrinsic curiosity, Bayesian inference and symbolic reasoning layers for representing knowledge and performing abstract thought, and attention and social interaction modules that enable the AI to focus its resources and learn from others. These components would work together in an integrated fashion, mirroring the complex interplay of cognitive processes in an infant. In conclusion, the infant-inspired model offers a promising and transformative approach to building truly intelligent machines. By drawing inspiration from the efficient and flexible learning mechanisms of human infants, we can move beyond the limitations of current AI and strive towards more robust, adaptable, and general artificial intelligence. This paradigm emphasizes learning through fundamental principles, active exploration, social interaction, and a developmental curriculum, offering a potential pathway to achieving the long-sought goal of artificial general intelligence. I am now happy to take any questions and comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.